Good afternoon from the U.S. Fish and Wildlife Service's National Conservation Training Center in Shepherdstown, West Virginia. My name is Ashley Fortune, and I would like to welcome you to a new mini-webinar series held in partnership with the USGS. This series is part of the Landscape Conservation Cooperatives and Partners Project Outreach Strategy. All right, let's get started. Sean, welcome.
Thank you, Ashley. This is Sean Finn. I'm Science Coordinator for the Great Northern LCC, and I want to welcome you to the Landscape Conservation Cooperatives Integrated Data Management Network Seminar Series. The Integrated Data Management Network is a project funded by the National LCC Network and included over 20 partner organizations, more than 50 investigators, and has been 2 years in the making. Over the course of the next 2 months, we will provide webinars every other Thursday to kind of give people a flavor of the eventual deliverables of the project, which will be available by the end of this calendar year. Okay, as we'll call it from now on, the IDMN, the Integrated Data Management Network Project, looked at ways to bring coherence to a rather fractionated information management landscape. Specifically, the project tries to address ways that the LCC partners dealt with the basic building blocks of data management, building and sharing science products with partners, securely storing those data for the long term, and evaluating ways to get those outputs to cooperators and eventually to the public. Over the course of the IDMN project, the scope was expanded to address ways to track projects that sponsored these scientific outputs, as well as build communication products and tools to help community members work better together. These efforts always kept other landscape-level efforts in mind, especially the National Climate Change and Wildlife Science Center and the network of climate science centers. The goals of the IDMN project, we assembled 6 teams of information management, natural resource, and communication specialists to evaluate and test different approaches. From this effort, the teams defined ways different LCCs and other landscape-level projects could not just coexist, but also constructively work together. Eventually, the idea is that the IDMN is not this, a standalone product, but the project winds down. We eventually expect the members of the folks that were involved in the IDMN, as well as the larger conservation community that include information managers, scientists, and natural resource specialists, will continue this partnership and collaboration through a series of communities of practices that will further the integration pathways for LCCs and other projects. These integration pathways should focus on data sharing options and fostering data integration partnerships, including data sharing, facilitating use of new integration options, collaborating on guidance documentation, and fostering hardware and software solution partnerships among the LCCs, the CSCs, and beyond to the greater conservation community. So for the IDMN project specifically, we had a number of specific deliverables that we promised at the outset and that this large team has been working on. To get these integration pathways started, the IDMN project generated a variety of products. These include metadata and data standards to help groups work together in specific domains, tools that let projects take advantage of partner capabilities and collaboration concepts. And essentially, a master product, if you will, of this entire effort will be a roadmap to interoperability, which will not only sort of frame what we discovered as an IDMN network, sort of develop a large, comprehensive document that describes how interoperability occurs. Today, we're going to, you can skip ahead here, just show the schedule real quick there. So this is a schedule of our webinar series over the course of the summer. If you don't have access to this series, you can contact Lei Ann Wilson, whose email will appear towards the end of the slideshow. And I just want to move along today by introducing Dell Long, Lei Ann Wilson, and Don Brown from the USGS Fort Collins Science Center. And they will be discussing one of the base products that we use to develop the integration concepts and pathways. And that is a product that's known as LCMAP and ScienceBase. So without further ado, welcome Dell, Lei Ann, and Don.
All right, thanks, Sean. This is Dell Long on the ScienceBase team at the USGS Fort Collins Science Center. Today we're going to talk about ScienceBase, or LCMAP, as Sean's already mentioned. I'll give a quick overview of what it is, and then Lei Ann will take over and discuss adding and managing items, as well as searching the catalog for existing items. And then Don will discuss LCMAP's GIS capabilities. Then I'll briefly discuss where we're headed, and we'll open it up for questions. So ScienceBase exists because it fills a niche. Researchers found that there just weren't any repositories focused on the needs of science projects. Data repositories were domain-specific, and once the data was placed in them, it was hard to find. Additionally, many existing catalogs were for metadata only. There was no place to put the project data itself. And finally, project managers needed a way to track and report on the products that the scientists were generating. What is ScienceBase? It was sponsored by the Core Science Systems group with support from NCC, WSC, and the LCC network. Although it has a user interface, its focus is on repository as a service, providing a place to store project information and data alongside relevant metadata, as well as providing access to those data via web services. Because of this, it's possible for a community to develop a mission-specific portal that meets their needs. Now, several communities have done this, and we'll see some examples of it later on in the presentation. So ScienceBase consists of several components. It serves as a metadata catalog of native sources, as well as metadata records harvested from other portals like the USGS Pubs Warehouse. It also serves as a data repository, especially for otherwise homeless data, or what we call long-tail project data. It may be easy to find a home for data that's in demand and will frequently be used by others, but what do we do with that long-tail data and less frequently used? So ScienceBase was created as a home for exactly this type of data. To help organize items in ScienceBase, we offer community spaces. Communities can have their own space, and searching from those communities yields items just in that community. Of course, searching the entire repository allows for the discovery of public items collected by other communities' projects as well. So we have catalog and repository services organized into communities. The next major component that Don will talk about later in the talk is its GIS capabilities. For example, uploading a shapefile or an ArcGIS service definition file results in the creation of map services that can be manipulated and used to display maps by applications outside of ScienceBase. And as I mentioned earlier, all these features are created on Web Service Foundation for use by the ScienceBase UI itself, as well as custom-built applications. So I've mentioned communities. In ScienceBase, each community controls its own space. Items can either be made public or limited to logged-in users with certain roles, or even limited to certain users themselves. So who can edit and view an item is determined on an item-by-item basis. So repository as a service, ScienceBase was built with service-oriented architecture in mind. So virtually everything that can be done in the user interface can also be performed by an outside application using REST services we provide. No user interface can meet every need of every group user, so providing these services allows communities to create applications that display and work with their data however they see fit. So this will give you a basic idea of what ScienceBase is and the services it provides. Now I'm going to turn it over to Lei Ann to discuss creating and managing items in ScienceBase in some more detail.
Okay, so today I'm going to be talking about, like Dell said, adding and managing items in ScienceBase as well as searching for items. First of all, in order to access ScienceBase, you need to go to www.sciencebase.gov. If you want to write or contribute to the catalog, you must log in. DOI users can log in using their email address and their Active Directory password. Non-DOI users can access ScienceBase as well, and they can get in an account by sending an email to sciencebase@usgs.gov with their first and last name, and we'll get them set up with an account. If you don't remember that email address, you can find it on the footer of our in ScienceBase when you go to the actual application. Once you are logged in, you have two choices to add data. You can either create a new record or import a file. Creating a new record is used when you're going to want to reference data elsewhere. For example, if I'm adding a citation to a URL to reference a pub, and I'll just add a link to where the pub is being hosted, I would go ahead and create a new record. Also, you could use it if you're just adding a web link to reference a data service elsewhere. Then your other option is importing a file. So this is when you're going to actually go ahead and upload a file from your local system or from your local network and upload it into ScienceBase. And you can upload about any type of file type into ScienceBase, but we do have some extra functionality when you are uploading shapefiles and geotiffs and service definitions, as well as if you're uploading a metadata file such with SGDC or ISO 19115. Now, we do have some file size limitation. You're not going to be able to upload a 50-gig file over the internet. That's just not technically possible. So we have some limitations due to timeouts from your internet service provider as well as some firewalls. But generally speaking, you can typically upload around 1.5 gigabytes to 2 gigabytes, but this also depends on your file type. So for more information about your file size limitations, we do have some FAQs referencing that as well. When you're creating or uploading an item, we need to think about metadata. Right now, ScienceBase is only requiring a title and a destination, which is where you're going to save that file within the repository. However, I really do want to encourage rich metadata to enable an easy discovery of your data, as well as provide additional information to your potential user. If you're uploading a metadata file, we do scrape it if it's SGDC or ISO 19115 as well as EML, and then we parse it out and put it in the appropriate fields in ScienceBase. Like Dell mentioned, once you have your item uploaded, you can also manage your permissions. By default, your item that you uploaded will inherit the permissions from the parent item, but you can configure your permissions all the way down to the specific item level. And you can, if you have a large group of people that you want to give permission to, we can set up roles, and you can assign a role to view or edit your item, or you can go ahead and just type in the username that you want to give permission to view or edit your item. So now I'll go ahead and bring over ScienceBase and do a quick demo of uploading an item. So as you can see here, I'm already logged in. So I'm going to go ahead and do an add item here. And once again, here's my choices. I'm going to either import a file or create a record. For this demo, I'm going to go ahead and import a file. I'm going to add my files, and I am just going to upload a metadata file, an SGDC one. And then I'm going to select Done Uploading, and at this point, it's going to prompt me. It says, hey, I see SGDC metadata. If this was an existing file, do you want to wipe out all the other metadata and replace it with this, or do you just want to update the missing fields on the record? In this case, since it's a new record, I'm just going to load the SGDC metadata. As you can see, it went ahead and scraped the metadata file. It grabbed the title, it grabbed the abstract and put it in the body field. It has a purpose. And then over here is my destination. I'm just going to go ahead and put it in my own specific workspace called My Items, and only myself can view and edit those items in that workspace. Let's see, here's from, and as you'll notice here, if you hover over the question marks, it gives you a few tool tips, and so the provenance is the origin of the data. And then you can see here it scraped the contacts as well and added additional contacts. And then if I want to edit or update it, I can go ahead and add additional ones as well. Then I can add an additional date to it, such as a publication date or a start-end date, where, let's say, if I didn't have it geospatial, if I wasn't uploading a geospatial file to the item and I just want to go in and do a footprint, I can go into the footprint studio and draw a point, polygon, or line, or add something, footprint, from our master extents table. How, or just special handling instructions, for example, contact Lei Ann to get these data. In this one, we scraped all the tags from the XML file, and we added these tags, but you can continue to add additional tags. You'll see here's the actual file. If I want to add more files, I can do so by clicking on the Add Files. An extension, Don will probably talk a little bit about this in his presentation, but for special files such as shape files, rasters, service definition files, it'll automatically add an extension to this record, and one of the common extensions used is if you're creating a project record, you'd want to add a project record, or another one is like a citation. If you're adding a citation to a publication, you would click on the citation. And then if you're adding external links, external web links, referencing other web services, you would go here and add your external links here as well. Or if you're, one of my projects has produced a YouTube video, I would go ahead and add the web link to the YouTube video here. So once I'm done editing my metadata, I'll just go ahead and click Save, and then it'll return you to your item show page. And here, once again, here's your purpose. It displays your tags down here on the left. If you want to, you can view it for our technical folks. You can view it in JSON. You can export it out into ISO XML, even SGDC. Once again, here's the body, and here's all your contacts. It does have a bounding box that it grabs from the XML file. And here's my web links here under the resources section. So I can click on one of those, and it'll launch me to the web link. Here's my original metadata file that I can download if I want to. And then since it's in my own workspace, it's not listed or added to another community, but if this item was of interest to another community, we could add it to another community. Or add a related link and associate it to another item. So if you're looking at this item, you might also be interested in another item. And then this is here, if you go here under Manage and you want to manage your permissions, this is where you would go in and manage your permissions. And right now it inherits the permissions from its parent record, but I could go ahead and set it to public, and I could go ahead and type in, if I know what specific role, I could type in a role here and add that role, or I could type in a user's name and give them permission. So that's just a quick rundown of how easy it is to upload an item in ScienceBase. Fairly easy. So I demonstrated how to upload one item through the user interface. But if you want to upload a lot of items, let's say you have 100 XML files that you want to upload, you're not going to want to do that individually through the UI. It's going to take forever, and you'll probably get carpal tunnel and whatnot. So we have this, what we'll call the WAF harvesting process, which is Web Accessible Folder. So you can quickly import or ingest SGDC or ISO 19115 or EML records by placing them out on a Web Accessible Folder. And then what you would do is create an item in ScienceBase. You'd go to that external links tab that I showed you, and you would add a web link to your Web Accessible Folder, save that file, and then on the item show page, you would process your file, and you would quickly ingest your records that you have hosted out on your Web Accessible Folder. So, for example, this week I was working with a PI from the Fort Collins Science Center, and he had over 413 SGDC files that he wanted to get uploaded into ScienceBase. He just dumped them out on a WAF, created a ScienceBase item, and we created 413 ScienceBase items with their original metadata attached to the file in under 45 seconds. So once you have your items uploaded into ScienceBase, you can search and discover them. So anybody can go to ScienceBase or LCMap and search for items publicly that are publicly available. A login is not required to search for items. And there are a variety of ways to search for items. You can search by a category, which I would equate to like a file type or an item type. You can search by a tag, or you can search by a location, and it'll only find items that have a geospatial reference. As well as for our advanced users, you can do an advanced search and do a more complex search. So I'll jump over to ScienceBase and do a quick demo on how easy it is to search the catalog. So I'm going to log out And so this main search box here is just a real, a simple search. So if I type in sage grouse and hit enter, it's going to find 426 search results. And then you'll see some additional filters here. So if you want to filter by those, you can, or you can go back and narrow your search down further. Let's do a browse by location. I can do a browse by location. Once again, it's only going to find items with a geospatial reference. I'll hit bound, and I'll draw a bounding box, and then I will hit search. And it found quite a bit of items, 41,000. Now, if I go into advanced search, there's a lot of other ways to discover items more for your advanced users. So, for example, if I want to search LC Map, I'm going to go ahead and pick my community, and I can add multiple communities as well. So if I want to search LC Map, and I want to search, let's see, the National Climate Change and Wildlife Science Center, and I can change my operators and or here. And then if I'm looking for a specific phrase, I can go down here and type in sage grouse, enclose it with quotes, and it'll find that exact term in my search. So then you'll notice here it generates a URL for the search. So if you like that search, you can copy that URL and save it for later, or email it to a colleague. Once I hit search, well, that wasn't a very good search. Apparently, I didn't enter something in. Oh, I put a and, didn't I? Okay, so it found, I'm just searching within the LC Map community on sage grouse, the phrase sage grouse, and it found 46 results. A nice thing is if you're a community manager, let's say I want to search on LC Map, and I just want to see what has been newly updated within my community. I can go in here and say, I want to show me everything that's been updated within the last month. And I hit search, and it shows me within my project community there were 369 records that were recently updated within the last month. Another cool search you could do is, let's say I want to search LC Map. I am going to clear that out, and let's say I'm meeting with some folks up on the Hill, and I want to show them some projects in their congressional district. So I've set my community LC Map. I'm going to go ahead and set my category to projects because I just want to show them the project records. And then if I go down here and do a search by location and start typing in my congressional district, I'm going to say it's in Alaska, and I hit search, and waiting. Do it a geospatial search, so it takes a little bit longer. And there you go. It found one record here. This project record right here, impacts of climate change and melting glaciers on coastal ecosystems. So that's, in a nutshell, managing and adding records in ScienceBase, as well as searching for items in ScienceBase. Now I'll go ahead and turn it over to Don, and he can talk about really the meat of ScienceBase, working with all of the GIS capabilities.
Hi, my name is Don Brown, and I'm a GIS specialist with the Web Applications team here in Fort Collins. So I'll talk about all the GIS capabilities and show one example of a partner portal, how they are consuming ScienceBase's GIS services and other services in kind of a front-end web application that's using ScienceBase as a back-end. So Dell already talked a little bit about how ScienceBase is a repository and a service provider. People add data, and then you're able to consume that outside of ScienceBase and other third-party applications. So and then end users are able to use ScienceBase and manage the security on their items and alter all the data in ScienceBase, so they don't have to call their website developer to make any kind of changes. So they can just bring those directly into there. So since Lei Ann's done a good job of introducing the ScienceBase user interface to you, I'll probably get started on just adding some geospatial files to ScienceBase so you can see how it's done. So I'm going to log in real quick. And you can kind of think of ScienceBase, its GIS capabilities, as maybe some of the basic functionalities of an ARC catalog. I don't know how many of you are ArcGIS users. It has the viewing capabilities with the added capabilities of starting GIS services, which are a really powerful tool to consume maps outside of ScienceBase. So we kind of leave it up to users to control how they organize their own folders. I actually already created a folder in here to just upload some sample items. I call it demo, and I put the date in there. So it's really easy to create new folders and organize items that way, just kind of how you do in Windows. So I'll go ahead and add item, and I'm going to start by adding a shapefile into ScienceBase, and it'll bring up a browse screen so I can look at everything I have access to locally. And I'll go ahead and grab just a shapefile here. It's actually a shapefile of polygons of the LCC boundaries, so it should look familiar to most of you, I would think. So it brought in some of the metadata information, how Lei Ann demonstrated earlier. It kind of grabs the title from the metadata too, so I'll just leave all that as is and click Save. And so it brings up a map of your shapefile and it makes the data available for download. You can download the separate shapefiles inside of a shapefile, or more likely you probably just click here to download all the files at once in a zip file. To note is to display this view of the shapefile, ScienceBase creates what's called a GIS service on a platform called GeoServer. It's kind of an open source GIS server technology, and it creates these GIS services that ScienceBase consumes to display the shapefile, and we also make these services available for people to use outside of ScienceBase. So if I click on the Advanced Services link, I'll get these different URLs here that are available for consumption. I'll do a quick explanation of what these services are. The first one is a WMS, which stands for a Web Mapping Service. And this is kind of the OGC, that's the Open Geospatial Consortium version of a mapping service. It serves pictures of your data. What that means is your data is rendered server-side on our ArcGIS or on our GeoServer, and then a picture of that data is sent across the internet to whatever application is consuming that service and displays it really quickly. Second one is called the WFS. That stands for Web Feature Service. When this is consumed, it actually serves the data. It doesn't just serve a picture of the data, and this can be consumed dynamically, and then images can be rendered client-side, or you can just download all the data that way and read it directly into geoprocessing functions and other things like that. So there's a time and place for both of them, and I won't go too far into that. I'll demonstrate quickly how you can consume these services. I would just copy the WMS link location, and I can go into ArcGIS Online and look at their viewer here. I can say add a layer from web. I can tell it it's a WMS service and just paste in the URL there, ScienceBase, and or to ArcGIS Online, and you can consume it that way, view your data. You can add other data to this to make mashups and view other data on top of this, all kinds of things, add other ArcGIS services. That's one way to consume these services outside of ScienceBase. So that's, we'll see what's available for shapefiles. ScienceBase also has kind of a little interactive mapper. That page is just giving a static view of the data. It gives you, we have a little interactive mapper, so you can zoom in and out on your data, get a better look at what's in there, maybe to better determine if you want to download it or not. There's other third-party applications out there that have much fancier mappers that we direct people to use. So I will now demonstrate what goes on when you upload a raster data set, and right now I'm going to demonstrate adding a GeoTIFF raster, since that is currently the only format that our Geo server reads. And let me find a sample raster, uploading. I'll say done uploading, and I have to add a title. Pick a place to save it, and click Save. So my raster gets uploaded. You see a picture of the raster. You can view it in the interactive map, just like I showed you for a shapefile. So everything's very similar to shapefile. You can also click on this Advanced Services link. Very similar to what I showed you for the shapefile again, but adds one more service endpoint, which is called the WCS, and that stands for a Web Coverage Service. That's a way to serve the image data across the internet. It's the actual data, it's not just pictures of the data. And if you're familiar with ArcGIS, this is kind of the equivalent of an ArcGIS image service, the open source equivalent. So with that, I guess those are all open source services. Those are probably not quite as popular as ArcGIS services, which I'm going to demo next, but they're growing in popularity and people definitely use them and consume them a lot currently. So to start an ArcGIS service through ScienceBase, which is what you might be familiar with using, you would first, I'm going to bring in ArcMap, which you might be familiar with. It all starts in ArcMap. This is just a map document that I constructed. It's a pretty simple one. It just has 2 layers in it, LCC boundaries, the GN-LCC highlighted, and some city points in it. So after I have my map document looking exactly how I want it to be served over the internet, I would go to File and I would share it as a service, and I would just save it as a service definition file. And I'd click through the screens. We have this all documented in ScienceBase, and we'll go into it too deeply, but it goes through this analysis steps, so it makes sure all the fancy stuff you do in ArcMap is compatible with serving online through ArcGIS Server. There's a few things you can't do, such as have an embedded GIS service in your ArcMap document. It's called cascading services. You can't do that, and a few other fancy things you can't do, but this will point them out to you, and then after you fix any errors that ESRI points out to you, you click Stage, and then it packages up the 2 files that I have here along with my MXD, my ArcMap document, and some configuration files, and it saves it all in one file with a .sd extension. So after that has been created on my local file system, I would go back into ScienceBase here, and I would click Add Item, and I would import a file again, and I would go find that file. I would open it. Give it a title. And click Save. And then ScienceBase right now is saving that file to a file system. It's unzipping this service definition package, and that's making a call to our ArcGIS server, and it's starting an ArcGIS service on this data set. So it's doing a lot of things right now, and to point out, this service definition file is available here in your item. It's available for download. End users can download that, unzip it, and then they get their MXD and everything available to use locally, and they get all the data locally too. So it'll look exactly how I had it on my ArcMap screen here, and end users will see that exactly. So after that service is created, here, if you click on the Advanced Services, you will get this new service called the ArcGIS REST service. And you can copy that and consume that in other third-party applications. You can see the map. It takes a minute or 2 to render, but here's the map, the online map. You can see it's symbolized the exact same way you had it in ArcMap. That's the powerful thing about using this. You can present data how you want it to present it. So then you can also view this in ScienceBase's interactive mapper. You can turn on and off different layers. just to get a view of what's in your service, and then to consume it outside of ScienceBase, I would copy that URL, and again, you can go into ArcGIS Online, very similar, but just make sure you say it's an ArcGIS server this time. I would paste it in. So now you kind of have two different things in your ArcMap online. You can turn the different layers on and off. You can see the legend for the different items. You can add more services. We also direct people to use other third-party applications to consume these services. This is the National Map Viewer. In here, you would do a similar way. They're all a little bit different, but I would say I want to add an ArcGIS service, paste the service in, and you get the idea. You add it, and it'll be added to your online map there. And then also there's a site called Databasin, which you may be familiar with. After you get an account with Databasin, you can go to create and import a data set in there, and you can say you want to import a map service. Say it's an ArcGIS map service. Paste in your URL there. There's also a second way in Databasin. We kind of partner with Databasin, so we allow you to actually just copy your ScienceBase item URL and paste it in here. And if you do that, Databasin knows the interface of ScienceBase well, so it kind of brings in all the metadata about this GIS service from your ScienceBase item. So it's a quick way to import an item. If you do it the other way, you kind of are required to add some metadata items about your ArcGIS service. So Databasin does a bunch of processing on it, and then you can open fancy maps, and Databasin also has some geoprocessing tools and identify functions and all kinds of other fancy mapping options to view your data. Same kind of concept. You can add more services to Databasin. You can catalog as many as you want, and you can put them together and make fancy maps. That's about it for Databasin. I think that's it for ArcGIS services. And after you get all your data, your GIS data in ScienceBase, I will show you one way one of our customers consumes all these services. This will be, I'll show you an example of the WLCI, the Wyoming Landscape Conservation Initiative. So these guys have all of their data stored in ScienceBase. I'll go to their community in ScienceBase. So as you can see, they have a bunch of different folders set up. They organized this exactly how they wanted it. And then what the unique thing is, so this is the Wyoming Landscapes front-end website, which has a lot of options, mapping options. And then the unique thing is they're kind of dynamically bringing in all this data from ScienceBase. If you notice, the folder structure here in ScienceBase looks just like the folder structure over down here. So this is dynamically reading that data from ScienceBase. You can open up these folders. You can click on these links to download the data. You can also click on the data and display it in the map. It's reading the GIS services directly from ScienceBase. So it's an easy way to manage content within ScienceBase and manage all the security, and then consume it in a third-party website and make it very user-friendly. I think that's it for partner portals. So with that, I might turn it back over to Dell to talk about catalog services.
All right, thanks, Don. We've seen a lot about what ScienceBase can do and what the services provide, and I'll just finish that off by talking about some catalog services. As I mentioned at the beginning of the talk, ScienceBase is built on a service-oriented architecture, so most of those services are proprietary REST services, besides the OGC services that Don was showing, but the actual ScienceBase REST services are proprietary. But we've been investigating standards-based services such as CSW and OAI PMH. Now, CSW can be used, for example, to harvest metadata from ScienceBase into another repository, such as a CCAN instance, for example. Similarly, we can support the basic OAI PMH protocol, which is being used to harvest metadata from ScienceBase into ORNL's Mercury platform as part of the USGS's implementation of the Open Data Initiative. So each collection in ScienceBase has its own endpoint, meaning that there's a URL you can provide to a third-party harvester that will only return metadata items that are nested under that collection item. So in conclusion, I just wanted to talk a little bit about what's next for ScienceBase. The ScienceBase team is currently working on requirements for the next phase of ScienceBase to ensure that it keeps up with user expectations. So if you have any suggestions, please feel free to contact us with ideas. We'll also be working to handle native metadata formats better, such as FGDC and ISO 19115 family. As they come out with new standards, we'll keep up with those and hopefully treat the metadata more as a first-class object than the scraping that we're doing now. We're also looking at technologies such as Amazon AWS and Grid FTP to improve our support for uploading and downloading large data sets. As Lei Ann mentioned earlier, that we have currently about a 1.5 to 2 gigabyte limit on the size of files that are possible to upload. And as you know, the cheaper computer resources get, the more data we have to deal with. So in order to try to support that, we're looking into those kind of technologies. And of course, once you have files that are that large in the system, how do you get them back out? And how do you slice them and dice them so that users can actually get that information and make it usable? And of course, we are working hard to ensure that ScienceBase provides a stable platform for our users to minimize downtime and in general be good stewards of the data that we're entrusted with. I talked pretty quickly through a lot of information. For more information about ScienceBase, please look at our help documentation at sciencebase.gov/about. And if you think of any questions after the talk or have general feedback, please follow these links and let us know how we can help you. And with that, I will go ahead and open it up to questions in the audience.
Excellent. Thank you very much. Our first question did come in via chat, and it's from Margaret. And you may have touched on this, Dell, in your closing remarks, but are the instructions that Lei Ann had mentioned posted on that website? I guess our participants would like some written down instructions so that they can walk through the process as well?
They're available on ScienceBase Help About.
On the ScienceBase, the answer there is go to the www.sciencebase.gov/about, and the information should be found in our wiki there.
Yeah, we have, and also if you go to the tool, you can just click on the help link, and that will take you to our help documentation as well as our FAQs.
Excellent. Thank you. We have another text question. It comes from Patrick, and it says, can someone give a brief overview of how the Geodata portal interfaces with SB?
So we have some integration with the Geodata portal where it can use, I think, shapefiles. We used to be able to use shapefiles from ScienceBase in the GDP to specify the area of interest, and it also could operate its processing services on rasters that were stored in ScienceBase. Really all the information I have on that, but you should be able to use any of the map services that Dom was talking about in Geodata portal using that feature.
Excellent. Our next question will come from Blair.
Yeah, actually, I'm in the office with Blair. My name's Nicholas Enright, and I just had a question about, I've seen a presentation on the National Geodata or Geo platform, and I was just kind of curious. I know that that's a relatively new initiative, and I was just wondering if there are any linkages between ScienceBase and that Geo platform, currently active or maybe planned.
It looks like Tim Kern wants to take that Geo platform question. If you could give him the microphone.
Yes. Hi. This is Tim Kern. I work with Dell, Lei Ann, Sean Finn, and Don. Yeah, the discussions with Geo platform have been going on for a while. ScienceBase has its own geospatial engine, as Dell and Don pointed out. Geo platform has similar technologies. It supports GeoServer, obviously ArcGIS Server. So we want to take advantage of the Geo platform to automate these services. We have a little bit of an administrative hurdle. There's no technical hurdle. Basically, we can work against the Esri REST services, doing exactly what we're doing with the ScienceBase geospatial engine. The administrative issue is that right now we need to make sure that we have escalated privileges for ScienceBase on the geospatial platform in order to programmatically do what we want to do. In other words, to automatically do the stuff. Don pointed out, you upload a service definition file, all that stuff. There's no human involved. It all happens in the background. And there's a little bit of we're just getting some paperwork out of the way to make sure that we can do that you need a little bit of higher privileges than normal geo platform users. We're still in the middle of those discussions. We just had a discussion this morning on it, but we're working toward that. Probably by the end of the fiscal year, we should have fairly good integration between ScienceBase and the geo platform. Did that answer your question?
Yes, thank you.
And Roy also has a question.
I'm interested in feature services with ArcGIS Server. They just released their collector app that allows you to do offline editing on mobile devices, and this would be a great way to serve that data. I was just wondering if you guys could maybe post the version numbers of the softwares that you're using so we can understand what the capabilities are.
Right now we're using ArcGIS Server 10.2.2, so we don't automatically start editable feature services on GIS services. We kind of do that on a one-by-one basis. But yeah, that is definitely something we give to the LCCs if they need it. Only thing that started automatically are ArcGIS mapping services and a WMS when you upload a service definition file, and KML service. So it is an option. There's also an option of consuming the GeoServer's WFS when you upload a shapefile or raster. That's the open source equivalent of a ArcGIS feature service.
Right, but in your service definition file, if you identify it as a feature service, that's fine.
It kind of doesn't look at those settings. We use a template and doesn't really look at those settings. So it's just the mapping service and the WMS and the KML that will actually get started, no matter what you click there.
Okay.
Because a little bit of overhead to start a feature service, you have to have data stored in an enterprise SDE-enabled database, and we don't currently do that automatically right now. It's kind of all saved on a file system. So it's kind of an on-demand feature.
And this is Tim Kernigan. To follow up on Don's comment, yeah, this is not an automatic right now, but we have been in discussions with the California LCC about, and with Esri, Larry Batten from Esri, as far as implementing basically supporting collectors in ScienceBase. And Larry and his group we're discussing with them as far as what we want to do as far as again, as Don pointed out, as a default we don't do it just because of potential load and potential just some other issues. We want to sort of limit that for right now. We think we can open that up to clearly some communities depending on their needs. So it's a matter of just sort of working with a community at a time on that.
Great, thank you.
Okay, our next question comes in through the chat, and it's from Aaron. It says, can you talk about how science-based references are harvested by data.gov, open data policy, and especially those users of ScienceBase that are not USGS? For example, LCCs that are using ScienceBase to store metadata and data sets. Are non-USGS users also being harvested by data.gov? And are they attributed to USGS if ScienceBase is being used?
This is Tim Kernigan, and that's a great question because that's come up with multiple communities. Right now, ScienceBase data, original data in ScienceBase is harvested, this is USGS data, is harvested, is part of the data.gov workflow. USGS has a workflow that works with several different catalogs to make sure that all of the different assets get properly put in data.gov without redundancies. What happens, though, is with other agencies, and our primary users outside of the USGS are the U.S. Fish and Wildlife Service, the Bureau of Land Management, Bureau of Reclamation. Those are the three primary other groups that are using ScienceBase. And what we want to do with those groups is not, by default, push metadata to data.gov. I mean, if we may have original data, but we want to work through those agency workflows. The Fish and Wildlife Service, I believe right now, is using ServCat for their primary distribution portal to the data.gov portal. And so we want to work with Richard Easterbrook and the other ServCat people to make sure that, again, the workflow is designated assets from LCMAP get to the repository, the outgoing repository that works with data.gov, and to make sure that that agency controls the workflow, and B, the agency gets proper attribution. Clear?
I think you might have broke off at the end.
Oh, sorry. We're just trying to make sure that, sorry about that. Yeah, I'm not sure how far we got. Anyway, bottom line is we want to make sure that the agencies control the workflow, whether it's Fish and Wildlife Service, Bureau of Land Management, Bureau of Reclamation, whoever. And so we want to work with those agencies to have LC-MAP as one of the catalogs that can supply that, we'll call it the authoritative catalog for the agency. So we do know that agencies keep source original data in LC-MAP, in ScienceBase. We want to work with those agencies to make sure that they control the workflow to get it to data.gov.
Excellent, thank you. And Aaron says, thank you, that was a very helpful response. Okay, I'm just scrolling through to see if there's any more hands that are raised. Yes, Suzanne. Ms. Worker, are you there?
Hi, this is Joel Reynolds with Western Alaska LCC, posing as Suzanne. So I just had a follow-up question there from Tim's comment. So my understanding from his explanation is that for getting anything that's hosted under LC-MAP into data.gov, then that is going to end up having to go through Fish and Wildlife Service through ServCat. Is that correct?
Yeah, the LCCs maintain data from multiple source agencies, and some of these data are funded by multiple agencies. And that's you're up in Alaska, and we know how there can be projects that have funding sources from Fish and Wildlife Service, from the LCCs themselves, from other federal agencies. And it becomes a little problematic for LC-MAP to make the decision on attribution. So what we want to do is work with the LCCs for them to identify, we'll call, who basically gets credit, who's the data.gov representative on those particular data sets, and then work with the source agency. So the Fish and Wildlife Service does have a model, a workflow model in place. BLM and Bureau of Reclamation right now are still working through some models. We've had discussions with them. So with Fish and Wildlife Service, we think we can pretty much help out if a data set is attributed to Fish and Wildlife Service. And it's going to be sort of an administrative hurdle to make sure that we understand how you tag the data set as far as that, quote, data.gov owner, or whatever we want to call it.
Yep, great. Thank you, Tim.
Lei Ann, did you have any closing remarks?
No, I think we're good.
Again, if anybody comes up with anything after the talk, be sure to send us email at sciencebase@usgs.gov.
Also, if you go to www.sciencebase.gov, in the bottom of the app, in the footer, we have a link for user feedback and a link for support as well.
And thank you again to the presenters and to our participants as well. Hope everyone has an excellent day.